Colonel Harinderjit Singh. Next we have Shri Praneeth Mehta, co-founder GalaxEye. He is the co-founder and vice president of sales operations at GalaxEye, a deep tech startup building India's first private multi-sensor satellite constellation. An IIT Madras alumnus, he led the only Asian team in SpaceX's Hyperloop competition. He was recognized as the best student entrepreneur at IIT Madras and is a TEDx speaker. At GalaxEye, he focuses on go-to-market strategies and bridging the gap between advanced space technology and real-world industrial application. Ladies and gentlemen, Shri Praneeth Mehta. Next we have Shri Rakesh Bhan. He is the CEO of Space at Samtel Avionics Limited, leading the development of LEO nanosatellites. He has over 20 years of experience across ISRO and NASA, including roles at NASA JPL. He previously founded the space group at Tata Advanced Systems and directed the TSAT-1A Earth observation mission. A recipient of ISRO awards, he holds 3 patents and has 35 publications in the field of SAR payloads and satellites system engineering. Ladies and gentlemen, we have Shri Rakesh Bhan. And last but not the least, we have Shri Karan Sajnani. He is the founder and CEO of Rudra, specializing in electronic warfare and cyber physical systems. His expertise includes signals intelligence, passive radar, and critical infrastructure defense. He is a NIST accredited researcher who has secured over 3,000 power plants globally. Sajnani focuses on building RF systems for spectrum dominance and detection, addressing vulnerabilities in satellites, ships, and national power grids. Ladies and gentlemen, panelists, reveal how intelligence becomes operational dominance. Over to you.
Good afternoon, everyone. And first of all, on behalf of my panel, I would like to thank the organizers for inviting us here for this topic, very pertinent topic, I would say, of strategic surveillance and intelligence. Although it's a different issue that, thanks to General Bhatt, toward the end of his slides, a couple of them was pointing exactly to what we intend to cover. But notwithstanding, just to add what he said, strategic surveillance and intelligence is actually the key. Those of you who attended the session yesterday, when there was session on the unmanned vehicles, so the amalgamation of unmanned and manned, amalgamation of unmanned systems along with the satellite is what would give you strategic surveillance. And strategic surveillance is important because if you see any doctrine on Google, you will find that there is one line that we always say in defense, that intelligence is targeting and targeting is intelligence. So everything is about intelligence. And when you talk about intelligence, the intelligence feed comes from strategic surveillance. Now, strategic surveillance, the sources can be UAVs, sources can be aircraft, it can be satellites. But since the UAVs part was covered yesterday in the complete session, hence our focus in this session would be primarily to the satellites. Like I said, the sensors, they give the inputs for strategic surveillance, and that is required, like it was covered yesterday by General Bhatt. In case once we detect a particular target, detect to decision cycle, or in other words, if I say sensor to shooter, that gets completed by strategic surveillance. It is strategic surveillance that gives us battlefield transparency and battlefield dominance. Now, the next question is, why should we discuss it here? We should discuss it here because till few years ago, it was actually the job of the government agencies to get into strategic surveillance. But after the space reforms, the private industry has really grown, and this is what will come out in the panel discussion, and the role that the private industry is playing. Whether it is Op Sindoor, whether it is Russia-Ukraine, how the private capacity can be amalgamated into the government sources to get into strategic surveillance, that is what we want the takeaway as far as this particular panel session is concerned. When you talk of strategic surveillance, it comprises of data collection, data acquisition, data integration, data analysis, and data communication. All this is highly vulnerable when we talk of cyber, because any cyber attack can paralyze the entire system, it can diminish the entire chain. So without wasting any time, because we don't have much time because we're already lagging behind. So what I will do is, luckily in this panel, we have a mix of government and private industry and the cyber. So I'll start firstly with the government. So Harinder, if you can, we can cover while seating to make it more interactive. If I can ask you to cover the present system of the strategic surveillance and in unclassified domain and the recommendations from your side. Okay.
Good afternoon. Am I audible? Thank you. So, when we talk about data acquisition, first, before acquiring any data, we have to be very clear what we are looking for acquiring. If it is just for target detection, then it's a different ball game. Otherwise, the weather part plays a very important part. 6 to 8 months in a year, the weather is bad in Indian conditions and neighboring countries because of the rains, water particles in the air, dew. So one has to be very clear what he is looking for. That converts it into the what type of sensor we are going to use, whether it's EO sensor, SAR sensor, hyperspectral, though it's at a nascent stage still, that also plays an important part. And nowadays, after Op Sindoor, a lot of emphasis is going into the use of UAV imagery and drones. So one has to be very clear what he is looking for. So once that part is clear, what you are looking for, and the selection of sensor you have done, then what comes is how you are going to acquire. As of now, the EO satellites, we have got a resolution of about, say, 0.6 meters to 0.8 meters. Here we lay a lot of emphasis on the spatial resolution. Everyone has been speaking about the spatial resolution. Spatial resolution, as everyone is aware, it is the ability to distinguish between two particles, two objects, and to see them differently. Lot of emphasis is on the spatial resolution. No one talks about the radiometric resolution of it. So you may have Indian satellites, Kato series, better in spatial resolution, but the Israeli satellites, being poorer in spatial resolution, will give you a better result. This I am talking as an image analyst because of the better spatial resolution. So one has to be very clear that it has to be a combination of spatial resolution plus radiometric resolution, and weather plays an important part that I have already mentioned. So once you are clear on what you are looking for, so one goes for the sensor selection. Once you have selected the sensor, then what you are looking for. If you are looking for infrastructure development, limitation of EO satellites is known to everyone. So if you are looking for just infrastructure development, one goes for SAR sensors. अगर आपने वही देखना है, how many bridges coming up, bridge cannot come up in say 1 month or 2 months. It is a progression where the piers come up. So if you have seen an image today and you want to re-image with EO sensors every day to see the progress, sorry, you are wasting your national resource on a thing which could have been used for some other better tactical object. So, say once in 10 days, once in 15 days, once in a month also, if the bridge is under construction, that can be taken, and the selection of SAR gives you a better dividend. SAR will give you better dividend at night also. If your adversary is the northern or the eastern neighbor, and what he did in Penangso, 3 months flat he constructed a bridge over Penangso. For that you require night imaging. Night imaging you get only with the SAR sensor. So one has to be very clear what sort of sensor he is going to use. Here I will, since we are talking about a data collection, I emphasize that lot of emphasis is again going into special resolution. That private company of America gives you 25 centimeter resolution, 30 centimeter resolution. What we are in Indian context looking for is a wide area imaging, which gives you say 1 meter, 1.2 meter resolution, but gives you a wider swath. Wider swath can be 60 kilometer, 70 kilometer, 80 kilometer with a 1.2 meter resolution. That gives you better dividends. The better resolution of say 25 centimeter, 30 centimeter, 40 centimeters will give you better dividends once you are closer or you want the specific identification of a object or equipment. Once you have collected the data, now it comes down to how you are going to interpret the data or analyze the data. Analysis, first it has to be, everything has to be culminated or stored in a GIS, Geographical Information System. Geographical Information System will give you analytical database of all the sensors, whether it's EO, SAR, you can use UAV, you can use drone data, you can use all type of sensors into the GIS database. And GIS database, the use is if you have got the temporal resolution analysis, it gives you the time series analysis also. When the object was made and how far it has come up till now. This will give you dividends not only during operations, it will give you dividends of how you prepare for operations also. One has to be very clear, if a new runway has come up, what are the use, why was that runway constructed? Whether it was constructed just for takeoff or landing, or it has other resources also available where you can have the aircrafts parked at night. So this temporal resolution or time series analysis gives you a lot of information which can be used during the crisis situation. Then comes the analysis part of it. Analysis will give you the temporal resolution, the persistent surveillance capabilities. Everyone today, once you have, everyone has spoken about the SBS-3 program which has gone up, inputs were taken from everyone, but now when we look for persistent surveillance, that is the word being used, persistent surveillance with 52 satellites is not going to come up. That is my personal take. Industry has to pitch in. The private industry has to pitch in and see if it's say morning hours, say from 8 o'clock in the morning, say about 6 o'clock in the evening, EO satellites will give you dividends. But what is there as part of the SBS-3 is again that 25 centimeter resolution and 30 centimeter resolution, everyone is pitching for that. So the swath of the image gets restricted. So again you are having about say 25, 30, 40 kilometers. Persistent surveillance involves when a boy has started from home till such time he comes to school. You can take it, the operational part, but I am just as a layman I am telling, when a boy starts from home and he comes to school, a father or a mother looks for, बच्चा मेरा ठीक ठाक चला था वहां पे पहुंच गया, and the teacher looks for how, when the boy started and in what time frame he has reached the end objective. So that is known as the persistent surveillance. In today's scenario, persistent surveillance, if you don't have wide area imaging, you're not going to get dividends. if you want to say about 10 kilometer, 12 kilometer, 30 kilometer swath, just imagine how many satellites you look for. So again, it comes down to you can have or you must have 40 kilometer, 60 kilometer, 100 kilometer, 150 kilometer. If you want to go from LEO to MEO, please go for that. This I am requesting the civil industry to pitch in, because no one talks about the dividends today, but tomorrow, once you go for persistent surveillance, it is not the Indian industry, it is the foreign vendors also going to, foreign industries also looking for all these things. Persistent surveillance with 30 centimeter and resolution and 20 kilometer of swath or 10 kilometer of swath. The best in the series today, what you call Maxar or Ventor today, gives you a swath of about 5 to 10 kilometers. How much money the government has, how much money the Indian Defence Forces have to ask for the data, and how much capability they have to give you the data is $1 million question. So one has to go for wide area imaging. Resolution may be 1.2 meters, cannot be 4 meters, because you are looking for enemy army targets, army equipment. Army equipment, if you are looking for 4 meter or 5 meter resolution, sorry, you are not going to get 90% of the equipment of the enemy defense forces. So once 1 to 1.5 meter resolution is good enough, one must go for say 100 kilometer, 150, 80 kilometer. So that is the need of the hour. Then comes the analysis. Most important part is the PSDA and the CEP. If you want to go for post-operational analysis or you want to go for temporal analysis, the most important is again the CEP. CEP you get by better resolution, and what I was talking the other day is how good is your base layer. If your base layer is 1 meter off, 1.5 meter off, 2 meters off, it is not going to pay you dividends. One has to be, anyone knows why we call this cartosat series of satellites? What is cartography? The main intention was to go for cartography so that you can get the best of the base layer. But because of inherent constraints and the economic power that we have, we had to convert that from cartography missions to imaging missions. So once all this thing has been done, you have got a good base layer, one can go for the dissemination part. As of today, we are disseminating through the normal channels of communication, whether it is from the data centers, it is through the medias are known, through satellite links to ground links or through SFTPs, whatever the best is available, the data is being. Now, what comes is whether it is through the satellite link or through the SFTPs or the ground layers, two parts which are important is, one is the speed of it and the protection of it. I think the protection will be taken up, but what is important is the speed. If you are going to image the target at say 11 o'clock in the morning, and the guy sitting at say Leh gets that data at about 6 o'clock in the evening, there is no use of it. So it has to be transmitted in the fastest possible way with the best of the cyber security in place. Thank you.
Thank you, Harinder, for bringing out the issues. I think three key takeaways from his talk. Firstly is importance of SAR because of imaging 24/7 and through weather. Second is importance of AI, and in AI the importance of predictive analysis. And last takeaway is integration of capabilities of the government and the private industry so that it's a potent ecosystem. Now, coming to the private industry, And we have industries which are sitting here, which are doing the first in the world. So we start with Galaxy. Galaxy is launching its first optosar satellite, and first in the world as far as fusion is concerned, like this was covered this morning. So I would request Pranit to just cover how this capability, to briefly cover about the capability and how this fits into the strategic surveillance.
Thank you, sir. And at the outset, thank you to the organizers for having us here. So quickly about us, we're a 5-year-old startup, not not ex-defense, not ex-space, yet solving the problem of overlap, right? So started with 5 of us from IIT Madras. Today we are a 100-member team based in Bangalore, building our own satellite. Why are we doing this, right? Let me give you a very classic example. All of us today use, the Olas and Ubers of the world, where we book a cab, you have it at your doorstep, and you go where you want to go, right? It is so convenient, but imagine a situation where you wanted to book a cab, and the app told you, sorry, it is cloudy, we cannot book a cab for you. Imagine you wanted to order food, and the app said, the weather is not favorable, we cannot deliver food to you. That is how the imagery intelligence works today, right? Because we rely mostly on optical satellites, we are often heard back with an excuse that because of these weather conditions, we are unavailable to get the data that we want, right? But GPS, having achieved its accuracies, its persistence, its commoditization, we are here where we are. That is the problem that we are precisely solving, right? We are, basically we synchronize an optical payload and a SAR payload on the same platform so that you have the availability of SAR and the intuitiveness of an optical image captured at the same time. Right. So that's purely our competency and what we like to call an optosar satellite. So this is the world's first such satellite globally. And when I say globally, I stress again on the fact that it's not just in the civil domain, but across. This is something that we validated well in depth. This becomes important because a lot of the capabilities, a lot of the requirements that we're dealing with, like Sir was mentioning earlier in his talk as well, most of the requirements, most of the conflicts happen during nighttime, low light conditions, and those are moments where you want to capture. Right? You don't want an image when it is 11 a.m. in the morning, you have a clear sky, but all the activities happened the previous night. You don't want an image 3 days later where cloud has happened, activities have occurred, damage has been incurred, and now you're only doing BDA. That is the kind of capability that we require. So when we are launching this satellite, today, after over 5 years of R&D, we have demonstrated this whole IP of ours across altitudes, and our satellite is in its final stage. We've completed all testing, and we are going to be launching it in less than 2 months from now. So as we speak, we are going to get capabilities that the world has not had before. Right? So that's what we are doing. Now, coming to the question, sir, on how does that impact, or how is that relevant to strategic surveillance? It is a paradigm shift. The reason I say that is, so far, most of our defense space initiatives, or most of our space initiatives for that matter, have been driven by what is the West doing, and can we do something to them. It's most of the times been the catch-up play, right? Even a lot of the earlier conversations have been about, they have 8,000 satellites, can we catch up to them? Right? Practically, it is not possible, and in my opinion, that is not something we should chase. We should rather chase quality instead of quantity. We don't have to launch 8,000 satellites to compete with them. We launch 800 satellites, but of much better quality, much better capability, we can still beat them, right? So this optosar is particularly important for us because of the cloud cover we face, because of the various conflicts in the past, including the recent ones, proving that you have cloudy weather during the conflict days and nights. These are the kind of requirements that we deal with today. And data doesn't solve the problem by itself, right? So when we say the relevance, you cannot expect that data comes in and solves all your problem. Right? And hence, we are also building AI layers on top of it, where we are able to regenerate optical image from SAR images. So we're building our own generative AI models. We're also building capabilities for object detection on SAR, which utilize assets, more than a few hundred crores of assets that are flying up in space today, not getting utilized. So we're building AI capabilities that enable utilization of those and essentially deliver the value that a user requires. We don't have to launch satellites just for the sake of it, just to increase the numbers and eventually not see them working. You'd rather want good quality satellites with intelligence capabilities that can derive information out of that data set and that delivering the end value. So unless we're all together, right, and when I say together, I mean the forces and the private sector such as ours, together chasing that goal, where the goal is not to have a large constellation. The goal is not to launch in 3 months with whatever minimal capability. The goal is to have the best in quality, and that has to reflect in our procurement processes, that has to reflect in how the QRs get drafted, that has to reflect in the capabilities that we expect. And that is an amalgamation of how we will achieve the best in the world capabilities and not say that, oh, we're catching up with these countries. I think that is some conversational change that all of us need to bring in. And at Galaxy, we're doing our part in building global first capabilities. So essentially summing up this very brief conversation, right? You have optical, you have SAR, each of them have their pros and cons. And it's beyond time that we start building what we need for us. So that's what we are building, OptoSAR satellites, launching soon, and our goal is to put up our own constellation that can deliver images every 3 hours, coupled with our own analytics and AI models that are built fully in-house. All of these owned, operated, built in India, and that's what we are here to offer. Happy to discuss more.
Thank you so much, Pranit. Key takeaways. I think very relevant, he said quality over quantity. That is number one. And this capability, like he says, 2 months down the line, the satellite is being launched. And once the data is successful, I think this would be a game changer as far as the entire globe is concerned. So, sir, I would say, if ISPA can also, push this, that actually the constellations like these, we need to get into our system. I think we need to we need to hold hand, and we need to buy the entire constellation. Probably he's saying 10 and revisit of 3 hours. If it was 50, the revisit can be that much lesser. And we, make a conglomerate of this and the present system that you mentioned, 52 satellites. I think this will be a huge capability as far as the country is concerned. Second key takeaway is AI on SAR. I think that is another thing. Right now, most of the companies in the entire globe are working on AI on EO, but if they are working on AI on SAR, and once again that model is successful, this will be a huge capability, as well as the third takeaway of converting SAR to near EO. So I think it's a great capability that we are building up. So thanks to you, Pranit, for bringing out all this. And now we move on to communication domain. That is SAMTEL, and we have Rakesh with us. What they are doing is also first in India. They are making a combination of IoT and TMTC. This will be first of its kind in India, which once again would be a game changer. So without stealing the thunder, if I can request you to just cover the brief.
Thank you, Adrian sir, and good afternoon to everybody. So maybe I should introduce first the company and then my thoughts on what has been happening here today. SAMTEL Avionics is the new kid on the block here. I mean, we have been trying to enter into the space now. Of course, SAMTEL is a 50-year-old company, and we have been doing a lot of avionics work, and we have been doing a lot of commercial display work. So I can see a lot of people here with the gray hair today. Most of you guys must have used your the CRT monitors, maybe in the computers or the CRT TVs. There's an 85% chance that the display must have come from the Samtel avionics. Samtel, back from 1975 to 2000, maybe up to 2008 or so, the market share of making those CRT monitors was almost 70 to 85% in India. So we were huge builders of that. And of course, the technology trend changed. It went to the flat panel displays, then to LCDs, then to LEDs, and the company had to change the plans accordingly. Now, we are making displays which are patented displays for all the aircrafts, head-on displays, with its electronics on the back end. It's ruggedized electronics. It is, of course, only company who provides it right now, so it's a patented one. So there is, if we see LCA coming up, if you see all the SCOI and all other aircrafts being upgraded, there is again an 85% chance that the display system will come from the avionics. And avionics displays company has been working with a lot of players in Indian context now. Now coming down to the the recent advancements, because Samtel is an R&D company, and there is of course return on investment is huge in the R&D. I mean, if you see about EBITDA or something, in commercial terms, it goes beyond 80% when you are an R&D company, R&D product, because you monopolize the product. So that's what Samtel's core DNA is. So we are now entering into two different domains. One is UAV, another is the space. As ABM sir said, space is something we are trying to enter into a unique domain. So let me give a context here. I come from a rich background of working with Indian Space Research Organization for 22 years. I worked with NASA JPL for the very prestigious mission called NISR. I was project director for 8 years. I'm basically a SAR person, what Pranit was talking about. I'm a core person from SAR by heart. I built SARs in C-band, L-band, X-band, S-band, dual frequency, UAVs. After that, coming to the industry, this is a different prospect. We see numbers, we see commercial, viability of the projects. This is where actually there is a gap. Today, when I was listening to a lot of speakers before me, nobody talks about the numbers. How do we, survive? How the commercial industry survives? It's actually persistence of survival for us rather than persistence of the, the image. So we will have to see the dual use of the technology. Everybody says that private sector has to pitch in, but private sector will pitch in at a cost which has to be compensated. So let me come back here. When I was working for RISAT-1, India's first radar imaging satellite, that was state of art, which came into, to ISRO after, we got a funding after 1999 Kargil War. That was the trigger point for building that technology in India. Now, I worked for that for 12 years, just to give a context what we are trying to do now in Samtel. So I worked for 12 years, and then we launched it in 2012. And I was working for NISR after that, and I was sitting doing some systems job, and I was crushed into the work. And I got a call after 4.5 years, around 2016 mid. I got a call from NASA headquarters in the morning around 11, and that was quite late in the US. And they said, "What is happening with RISAT-1?" It had disintegrated. And nobody in ISRO knew about it. Of course, their capabilities to see to the space, what is happening in the space, was much more than ours. And we tried to intervene what has happened to our satellite. And after a week, we got a report that satellite got disintegrated over a different continent where it was not in our contact at that point of time. We were not supposed to have the contact of the satellite when it was out of our range. So we were monitoring the satellite from India and the adjoining countries, and that happened way over the China. We could never figure it out. What was our satellite doing that point of time? Now coming back, fast forward, what we are trying to do now is trying to see that our satellites are under our control and communication is 24/7. So we are building an infrastructure in the LEO, and maybe little more than LEO orbits for telemetry and telecommand. It's actually I'll say literal terms, it's a ground station in space which can see your satellite all 24/7. And that can see your satellite, plus it can command your satellite and get the telemetry from the satellite 24/7. there will be no dead zone. And this capability is required for any constellation built for the strategic surveillance, even for ISRO. And I think our adversaries, in the Eastern and the Western and everywhere, and maybe the other continents, the advanced nations, they do have these capabilities right now. I will again reiterate here whether we are going to be the trendsetters or we are going to be the followers. See, what we are building right now, mostly in the space, has been a state of art, but we need to be the trendsetters. See, sometimes actually, the investments in the space are forced on us because recently we were fighting actually in, the western border, and the northern borders actually gave them the capabilities. So we can't just see that one enemy who doesn't have the capability as of ours, but the other enemy will actually pitch in and provide those capabilities to the, and they will jointly, fight us. So we can't be just waiting and following the trend. The question comes here is how much we have inflicted, from our side, the terror and I will say the investments which has forced our enemies to invest into that technology because India has that. We have not been able to do it till now, but we need to do that. So this is where we stand right now. And I remember that 20 years back, we had a satellite which was called TES, which was made by Dr. Kiran Kumar Padmashri. He was that time, he was my reporting boss for some time. We were comparing those images with Iconos satellite. Our, I will say we had chosen our competitor as NASA. Now coming back again, fast forward to this point, who we are comparing with today. I will say choose your enemies wisely, whom you are comparing with, who you are competing with.